This is Sirup Datta from Expert Mathematica. Today I will be discussing a question from CSIR NET 2023, question number 36, question ID 704061 from complex analysis. This question is from part C and it has 4.75 marks. So multiple options may be corrected. We have to check each and every option. So given that for a given integer k, consider a contour integral ik. This ik is given by integration of 1 mod z equal to 1 z to the power it was z by z to the power k dz. So first option is given that ik is 0 for every integer k. So for k less than equals to 0, the function f z e to the power z by z to the power k is analytic over that domain mod z less than 1. So the contour integral by Cauchy-Borchardt theorem, contour integral will be 0. So ik is 0 for k less than equals to 0, and we need to verify for k greater than equals to 1. So for that we need power series representation of exponential function. Exponential function have power series representation like that: z square by 2 factorial plus z to the power k minus 1 by k minus 1 factorial plus z to the power k by k factorial plus z to the power k plus 1 by k plus 1 factorial dot dot dot. And e to the power z by z to the power k is given that 1 plus z square by 2 factorial plus dot 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 plus z to the power k minus 1 by k minus 1 factorial plus z to the power k by k factorial by z to the power k. So coefficient of 1 by z is given by 1 by k minus 1 factorial, and we know that if we have a function fz and we know its coefficient of 1 by z, then its integration over a contour, suppose c, is given by 2 pi I into its residue at the point z equal to z naught, and residue is given by the coefficient of power series representation of 1 by z minus z naught. So here in our domain mod z less than 1, we have z equals to 0 inside, and we need to find out its residue at z equal to 0. That means coefficient of 1 by z, and coefficient of 1 by z is given by 1 by k minus 1 factorial. So the integration e to the power z by z to the power k dz is given by 2 pi I into k minus 1 factorial, which is ik for k greater than equals to 1. So ik we have 2 pi I by k minus 1 factorial for k greater than equals to 1, and for k less than equals to 0 we have 0. So option 1 is false and option 2 is true for that. And option 4, and for option 4 it is easy to verify, since we have ik is given by 2 pi I by k minus 1 factorial, and if we take mod of ik, we have it is 2 pi by k minus 1 factorial, which tends to 0 as k tends to infinity now. And option 4 is given k tends to infinity, mod of ik is infinity, which is false. We just need to verify ik is mod of ik is less than equals to mod of ik plus 1 for every integer k, which is true or false. And I am verifying for k greater than equals to 1, and for k less than equals to 0 it is easy to verify. So for k greater than equals to 1, we have mod of ik is 2 pi by k minus 1 factorial, and mod of ik plus 1 is 2 pi by k factorial, and for k greater than equals to 1 we have k factorial. Sorry guys, let me erase this. K factorial is greater than equals to k minus 1 factorial, and if we take the reciprocal and multiply 2 pi by both sides, we will get 2 pi by k factorial is less than equals to 2 pi by k minus 1 factorial, which implies mod of ik plus 1 is less than equals to mod of ik, and option 3 is given that the converse portion, so it is false. So only option 2 is correct and other options are false. So you students will get 4.75 marks from part C very easily if you apply, if you done this question. So you guys, if you like this video, please don't forget to hit the like button and subscribe button, and thank you guys for your time.